Alright, this is Math 8, Chapter 1, Lesson 9, looking at estimating roots today. We're going to take what we learned in the last lesson about square roots and how they work and do some estimation, which means we're going to try to see what number is close to the actual answer. We're not going to actually solve it today, we're just trying to figure out what is close there. And the way they explain this in your book today, or your lesson, was to take a look at a number line essentially and kind of take a look and say, well, if I'm looking at the square root of 8, I know that I don't know a whole number that's the square root of 8. I know that the square root of 4 happens to be 2, and the square root of 9 happens to be 3. So the square root of 8 is going to lie somewhere between 2 and 3, and I have to determine what it's closer to for today's lesson. Is it closer to 2 or is it closer to 3? And since the number 8 happens to be closer to 9 than it does to 4, we would say that a good estimation for the square root of 8 would be 3 because it's a little bit closer over there. Again, it's an estimate, it's not the actual number there. You could use a calculator to find out what the square root of 8 is going to be, but that's not the point of the lesson today. You have to be able to estimate that, and it's one of your standards for 8th grade. So let's take a look at some samples today that are on your homework on the independent practice on page 85 and on from your textbook here. When I look at the square root of 23, I want to ask myself, all right, well, what do I know? I know that 4 times 4, or 4 squared, equals 16. And I know that 5 squared equals 25. So the square root, if I had a number line, the square root of 16 is over here at 4. And the square root of 25 is here at 5. And we're dealing with the square root of 23. Well, the square root of 23, to me, appears to be much closer to 5 than it does to 4. And so we would say the square root of 23 is about 5. Again, it's not fully 5, but it's close to that one. Number 3, we have 15.6. Now, don't get confused from what we did last time and try to say, well, what could this be? Slide decimals over. We're looking at the actual number 15.6. So we look at it this way. We say, well, I might have 3 squared is equal to 9. And 4 squared is equal to 16. Again, on my number line, here's 3 squared and here's 4 squared at 16, right? So square root of 16 is there and square root of 9 is there. This is a square root of 15.6, which would be somewhere about here on the number line. So we would say that square root of 15.6 is about 4. Okay? Simple as that. Now let's take a look at the number 5, the cube root of 22. Cube root of 22. Same idea. So what do I know? I know that 2 cubed is 8. And I know that 3 cubed is 27. So on my number line, if I have 2 right there and 3 right there, and the cubed root of 8 and the cube root of 27, we're trying to find out where would the cube root of 22 be. It would probably be closer to here than it would be to there. So the cube root of 22 is somewhere around 3. And we'll leave it there like so. Number 7, it's the same idea. In this case here, that's a really large number. I'm not really sure what that's near, but I know that this gets really, really close to 1,000. And what I do remember is that 10 cubed is equal to 1,000. Okay, so on a number line here, I'd have the cube root of 1,000 is right here at 10. I don't know what the cube root of 9 is going to be off the top of my head, but 989 seems really, really close to that, and I'm going to go with 10 because that's way too close to have something else squeeze in there. In reality, the cube root of 9, what we look for would actually be 729, so that's farther down there. But you may not know that, and that's okay. Let's take a look down below at some ordering from least to greatest. I have the number 7, 9, square root of 50, and square root of 85. What do I know about these numbers? Well, I might recognize that 50 is pretty close to the square root of 49. Now the square root of 49 is actually 7. So this means that this value is greater than 7. I know that the square root of 81 is equal to 9. This number seems to be bigger than that, so it's bigger than 9. So my smallest number is actually going to be 7. Square root of 50 is a little bit bigger than the square root of 49, so that would come second. We know that 9 is less than square root of 85 because the square root of 85 is greater than the square root of 81, which is 9. And that becomes our numbers in order from least to greatest. Alright, let's turn the page and look on the back side here. We're going to take a look at a couple problems from the extra practice pages on page 87. First of all, number 26. It says estimate the solution to each equation to the nearest integer. So we have y squared equals 55. To find out what this is going to be, I would take the square root of both sides. So y is equal to the square root of 55. But again, when you take the square root of 55, it's plus or minus the square root of 55. So now I want to ask myself, what is nearby the square root of 55? I know, for example, that 7 squared equals 49, and I know that 8 squared equals 64. So on a number line here, here's the square root of 49, here's the square root of 64, and 55 seems to be, in terms of numbers, about 6 away from 49, but it's 9 away from 64, so I would say it's closer to the 7. Now, because it's plus or minus, this means that my solution could be 7 or it could be negative 7. Both answers are possibilities on this problem, 7 or negative 7. Let's take a look next door at number 28. Again, same idea. I'm going to take the square root of both sides. And remember, this is the square root of 6.8. So, what do I know about my numbers? I know that 2 squared is 4, and I know that 3 squared is 9. And 6.8 is somewhere in between those. So if this is the square root of 4, and this is the square root of 9, I have to ask myself, where does 6.8 fall? So let's pretend I have 5, 6, 7, 8, 9 as my other points along the number line. And this is 5, this is 6, 6.8 would be somewhere about here on my number line. So it's pretty close to kind of in between both of those numbers. Hard to say exactly, but that's 2 and that's 3, but it seems to go a little bit more than halfway, so for the sake of argument, we're going to say it's closer to 3. But remember, we took the square root of both sides. The square root of both sides would mean that this could be 3 or negative 3, and that would be just fine. One last problem here. We have the volume of the cube given. Volume is, we got to estimate the side length of the cube to the nearest integer. Use the formula volume equals s cubed, which means we want to find what s is equal to. So s cubed equals our volume. S cubed equals 210. So I take the cube root of both sides to find out what that's equal to. Well, the cube root of 210, not sure what that's going to be exactly. However, if I look at my notes from before, I know and recall that at 5, the cube root of 5 is 125. And the cube root of 6 is 216. In case you're wondering, how did you know that so fast? Again, I don't have that memorized. I have my little note sheet from last time that I can take a look at and say, oh, there's 5 cubed, 125. There's 6 cubed, 216. And it helps me plot my point. So 210 is going to be right about here. So it tells me that it's pretty close to 6. So the estimate for the length of one side of a cube would actually be 6. I can't have a negative length, so I'm just going to leave it as a whole number, 6. Or in this case here, it's inches, so technically it would be 6 inches. Alright, hope that helps you with your work today. Good luck on the rest of the problems.